Now we have the what is speed and what is velocity, the difference between the speed and the velocity. So to understand that, just try to give the idea. Let's suppose they have given some diagram over there. So let's suppose that this car is moved from this and on a circular arc and reaches here at this point. Let's suppose it reaches here at this point. So if you see it carefully, the speed is let's suppose 20 meter per second. So at this point also it is 20 meter per second. Actually, the speed is a scalar quantity. It just tell the magnitude at what speed the car is traveling. We are not going to be point out any kind of the direction in the speed, but the velocity is a vector quantity. You're going to say the car is moving initially in the 20 meter per second towards the north direction, or then it start moving in the northeast direction. So this slightly, so you have to represent here. So let's suppose I say it is on the west side or the east side. I'm going to mention that if the car is going and you point it out, it is 50 km per hour to the west side of me, on the west side. So it is means you are telling the vector. Just think it like this. Vector have the magnitude. You are telling some kind of the magnitude with that, and the direction also. You are associating the some kind of the direction with that. So in the speed, you do not require that. Speed is just 20 kilometer per hour, that the speed is that is traveling. So the unit is, you can write it as per your convenience. The unit is, so if I had to define the speed I am going to define is the average speed is the rate at which the distance is covered. The velocity is at what rate the displacement is changing. Another one is the average speed is total distance by total time, and average velocity is total displacement is actually, I'm going to say displacement, because total displacement is technically it's the same. Displacement is displacement only. We do not talk about the total displacement because it does depend upon the initial and the final position. So it is just a average velocity is nothing but total displacement over the total time that we have it, and that is a vector quantity. This is scalar quantity that has magnitude only, and it is the magnitude as well as the direction. It is always positive and it is can be negative, and because it is a vector quantity, so it can be negative also, it can be positive, zero. So directions you are going to define in the physics. So you are going to tell which one is positive, which one is negative. If the car is moving on the right side of me, I can say this direction is positive. So I'm going to say 20 meter per second to the right side, that is positive. I can choose it. If on left side I'm going to move something, so I can say negative. So negative, positive will tell the direction of that. If so, you can think it like this. Let's suppose that a car, this is the graph. What that positive velocity means is, if the car is moving away from you, it is going away in the positive direction that I chosen it. This is the positive direction. So I'm going to say velocity is positive. So I'm going to say this is positive 20 meter per second. It is going away from you. So let's suppose you are standing it here. So you are standing it here. From you, it is going away. So this is positive 20 meter per second. So if it is something is coming towards you, so you are going to say it is negative. So it is on the car, when the car is going to be moved, is on the left side of you. So we are going to say, or something is coming towards you. So the displacement, if you see it carefully, the displacement is decreasing because it is coming towards you. So in that case, the velocity is negative, because velocity is defined as displacement over time. Change in the displacement over rate of the change of the displacement over time. Speed is defined as how much the distance over time. That is a scalar quantity. Velocity, speed is a scalar quantity. Velocity is a vector quantity, that we have it. So you should know understand the meaning of vectors properly, means which one is negative, which one is positive. Because when I'm going to discuss the graphs and something, bunch of the things, it should be important for you to understand these basic idea of the positive negative. Change can only if the magnitude slow and the something. So this is going to be changed. So the speed is only going to be changed when the magnitude is going to be changed. Magnitude, I mean, so that 20 to it become 30. So the speed up. But in the velocity going to be changed because it is a vector quantity. If the direction of the car is also going to be changed, it is going to be changed. If the magnitude going to be changed, it is going to be changed because velocity is a vector quantity. Vector quantity means that it have both magnitude as well as the direction. If any of the thing will change over there, it means that quantity is going to be changed. So the velocity is going to be changed if the direction is going to be changed. That you have to keep in the mind. So if any object is moving on a circular path, so if you see it carefully, if it is moving with the 20 meter per second, this is also moving with the 20 meter per second. So speed is the same when it is moving, but its velocity is changing because direction is changing. Obviously, when the magnitude will change, both the quantity will change. Now let me give the idea of the something about the what is constant velocity motion is or uniform motion is. The uniform motion, the motion in which the distance traveled by the object in the equal interval of the time is equal. So the distance is going to be remain the same. If my hand, my hand is moving, if I'm going to say it is moving the constant velocity, it means every 1 second it is traveling the same distance. Every 1 second, as the second is happening, so every 1 second it is traveling the same distance from this position. So this is, we call it a uniform velocity or constant velocity that we have it. So you can see it here also in the graph. So the in the same interval of the time, same distance traveled. It is not going to be travel the more speed. So it is slow and it's fast. This is not the example of uniform velocity because it's slow first and it's speed up. So this is not the case when the car accelerate, means the car increases the speed. We are not going to be talking about that. So that is not uniform velocity. Uniform velocity is the velocity at the same rate the distance is changing in equal interval time. In equal interval time, the same equal distance is covered. Thank you. Let's try to understand the difference between the average velocity and instantaneous velocity. As the name is suggesting, average velocity is how much the overall the displacement that you have done and by the total time. So that is the average. On an average, how much the speed or the velocity it is. So we are going to calculate the displacement that he covered and the divided by the total time. Instantaneous, it means at an instant only we are talking about. Let's suppose the car is traveling. At that instant, what is the velocity of that car is? That is instantaneous velocity. So let's suppose that during the journey, you started from the home and you go to the market. So you moved and you go to the market in that duration of the time. Your speed of the car is going to be changed. Obviously, you are going to be speed up, you are going to be accelerate also, you are going to be apply the brakes also, then you're going to be stop for a few minutes in the stop and then you come back. In that also, your speed of the car is not going to be remain the same throughout that. It is going to be changed. It might become 0, it might 30, 40 and something. So it is going to be changed. So if somebody asks you what is the you start from the home and go to the shop, let's suppose. So in that duration, you change basically the speed is going to be changed throughout the motion and increase, decrease, increase, decrease. But if somebody, the shopkeeper will ask you what is the average velocity that you have it, so you are going to say how much the displacement that you covered from the house to the shop and how much the total duration that you taken to reach it over there. Let's suppose you taken the 2 hours to reach it over there. So total distance over total time. So the total displacement that you traveled over total. This is average you're telling. But as a instantaneous is the velocity that you're at that time when you're traveling. if your friend is going to be ask you what is the velocity of the car at that moment, you said it is 20 meter per second in the north direction. So at that moment, the speedometer of the car will tell you the exactly the at that instant. So on that graph paper, how we are going to do that one? So you can understand by this simulation. So let me play it. So just see, before it is sending this displacement is negative, and now you have displacement is becoming positive as it will come here. So its displacement become positive. Now at the 6 second, it reaches to the maximum displacement, and then it coming back. So the displacement is decreasing eventually if you see it carefully. So this is the actual that is travel. So at an instant, if somebody asks you, let's suppose I ask you at a what the speed will be at this point. I will come to the graph also, but at this point I had to find it out. So this is the graph. I'm going to find out the slope of the graph to find out at that instant what the velocity. So at that instant, how much the distance is traveled over this one. So for that, I'm going to find out the slope of the graph. Smoothly, we will learn in the graph also more depth of that one, how we are going to exactly draw that one. So this is average. So from here to here, this is some kind of the average. So how much the total time that you have taken it and to travel that one. So these are the ones of things that we have it. So total displacement. Displacement is how much the displacement that you moved it from -1 to this point, how much that you moved. This is your displacement will be. So in this way, we are going to look into that. And if I show you the formula, so in this case, the 8 is the total, we have it. And right now, I think I moved it slightly, this point. And let me start from here. This is the 8 second, and the how much the display, how much the you have the displacement on the top. So this is average type of that. When I'm going to talk about it's at an instant only, let's suppose somebody asks me at this point. So this is a instant. At an instant, the speed is this much. So I'm going to calculate the slope of the curve. By the way, we will learn more. This is instantaneous velocity, average velocity. So go have the vector quantity, you have to tell the direction also.